Hey, I found it back here. I figured it might help.
Beautiful. Isabella. About our trees. I know it's awful. Awful to read through. But, and then you start dealing with like fractions and fractions of what's left, and then it's like just a giant headache that I don't like to deal with. So, what's our strategy here, guys? Make up fruit, make up numbers. And what number should we make up? Given our answer choices and the strategy we talked about earlier. 60. So we're going to start off and say that there is a total of 60. Okay, now let's see, let's work through it. 20% of the trees in the orchard are apple trees. So how many are apple? Ah. Whoa, don't know what happened.
Make it big again.
Hold on. Oh man. Okay, rise again.
Same program for.
Oh, no, it's going better.
When in doubt, refer to
It's
the
gonna get so much better, guys, I promise.
Let the fruit.
What happens when you put it right here?
Open the fruit pack, it'll give you your knowledge you need.
Oh, look at our total of 60 back. 16.
Thank you, sir.
So I bring it to
You
you.
use Windows more than I do. I'm an Apple guy.
Manage my classroom of like 20 kids.
People are getting away. I'm like, oh my.
So guys, 20% of 60 is what? 12. So we've got 12 apple trees. And it says a third of the trees that are not apple. So let's, let's start out there. It says a third of the trees that are not apple trees are cherry. So how many are not apple? 48. Not apple. Good. And then our cherry, a third of those are cherry trees. So how many are cherry trees? 16 are cherry. So when I start to solve these problems, guys, I don't ever worry about the fact that I have no idea where I'm going with it. Sounds really bad, right? No, but it's true, because I think one of the biggest problems that I've noticed with students is that they expect that they can look at a problem, read all this, and they just automatically should know what all the steps are. No, sometimes you just have to figure out what information you have, and then it'll all come clear as soon as you get towards the end, and then you'll know exactly what you're trying to do. But until then, I just write stuff down. I just say, okay, this is what I know, and if I know that these are apple, I know these ones aren't apple. I don't know why I care, but right now all I know is that I need to know that. Okay, or maybe I don't need to know that, I don't know, but it's not going to hurt me to have it. And then it says, if 3/4 of the trees in the orchard are fruit trees. So how many are fruit trees, guys? 45, right? Because it's 3/4 of the trees in the orchard. So we're back to that first number, that total of 60. So we know that there are 45 trees that are fruit trees. And the only types of fruit trees are apple and cherry and plum. What fraction of the trees are plum? So plum is a new one we haven't talked about yet. So we know that there's 45 fruit, and we know how many apples there are, right? We know that there's 12 apples, and we know that there are apple trees, rather, and that there are 16 cherry trees, which means how many are left to be fruit? So we have to do the plum. 7? 17? Okay. So we have our total of 45, right? Minus our 12 apple, minus our 16 cherry, and we have 17. Is that right? I'm confident from you, so I'm trusting you guys. You sound like you know too, so we're good. So then the question is, what fraction of the trees in the orchard? So again, we have to make sure that we're paying attention to what number we're taking as a fraction of. So we have 17 out of the 60 in the orchard. Any questions on that? The other 15? Yeah, they were
money trees.
They were money trees. There were money trees in the orchard. Any questions on that, seriously? So again, if you did this and got it right with fractions, good for you. It is, I don't like fractions, I don't like dealing with them, I don't have to, if I can deal with whole numbers. And also guys, there's a strategy that, because the SAT is really, and the PSAT are very much focused on real life scenarios as much as possible. No one's gonna have an orchard tree, or an orchard with this many trees, but generally, whenever you can put things into a perspective that you can actually like visualize and see happening, you're gonna be better off. When you're talking in terms of abstract thoughts like fractions and decimals and things that you can't concretely nail down to something, that's when your brain is gonna get lost because you can't go back and your subconscious won't check that math, right? Because you're just assuming it's going right, everything's going in the calculator. But when you start dealing in what is really happening, what these things really are, then if you get a crazy number, there's that little thing, you're like, wait a minute, that doesn't make any sense, which may not happen otherwise. Any questions? All right, fantastic. Light bulbs. Big problem with the light bulb factory. Let's see here. Who wants to read? Let me just take volunteers. Volunteers. Someone who feels really inspired about the light bulbs. I thought so. Can you read this from me? Thank you.
At a light bulb factory, 1 out of every 30 light bulbs produced is defective. 92% of the defective light bulbs are discarded at the factory, and the remaining defective light bulbs are shipped to customers. If 1,200 defective light bulbs are shipped to customers over the course of 1 year, how many light bulbs are produced by the factory during that year?
All right. So, talk to me, guys. What do you think our strategy for this is going to be? How about strategy right now? Working out mathematically, yeah, the answer choices, right? Because here's the good news. How many were produced that year? Well, it's got to be 300,000, 450,000, 500, 440, or 600,000, right? Otherwise, it would be a terrible, terrible problem because there would be no answer. So, we can use those. Now, we would start with C, because it's in the middle here, but if we look at this, 1 out of every 30 light bulbs is defective. So, what's a problem there? What can stop us and not go through the hassle of trying 500,000? Yeah, they're like broken before we start because we're getting fractions of light bulbs, right? Like this is not a good start to our day. So whenever you know that you're going to be dividing by something and you know that it doesn't make any sense logically for you to have a piece of a light bulb in like before we get to the end when they're all broken, then you know you want to try to find something that's going to be divisible. So which one do you want to try, guys? What's a good spot? Anybody have any luck with the light bulb problem? Okay. So let's go with 450,000, guys, right? So here's how we go. We say, okay, we've got 450,000 total. Guys, and also notice that I am labeling whenever possible. Another mistake that a lot of students make is they work out a lot of math and they get a lot of numbers, but then they look back at their numbers and they have no idea what the number was or why they have it. And they just have like a random 356 on their page and it doesn't make any sense because it's not attached to anything. So as often as you can, keep your notes clear, keep your numbers labeled. So then what happens? It says 1 out of every 30 light bulbs produced is defective. So how many are defective, guys? 1 out of every 30. 15,000 are what? Defective. Good. Now what happens? It says 92% of the defective light bulbs are discarded. So if 92% are discarded and the remaining light bulbs, so if 92% are discarded, what percent is kept? 18? 8. I meant 8. 8 are kept. So what is 8% of 15,000? 1,200. So that means the 1,200 were shipped. Is that what we're looking for? Yes. So what we did, guys, to review, we started with one of the answer choices. Then we calculated that 1 out of 30 were defective. Then we realized that if 1 out of 30, or that if 92% were discarded, that means the other 8 were kept. The other 8 were kept and shipped. We figured out what that was, and it was 1,200. Now, given that the problem itself says the 1,200 were defective, we started with the right answer because we got the right answer at the end. If we would have gotten anything besides 1,200, we would have known that we went with the wrong answer choice. And this is the benefit, again, of starting in the middle, because if we saw that that was either too big or too small, we would also know which direction to go. Any questions on that? Awesome. Okay, number 11. Who wants to read number 11 for me? Eliza is what I said.
If y is a positive number, which of the following is equivalent to increasing y by 40% and then decreasing the result by 50%?
Awesome. So, guys, what's our strategy here? Make up a number for y. So I want everyone to take the next 2 minutes. I want you to make up a number for y, and I want you to work it out. We're going to go through it. Raise your hand if you already made up numbers before for this problem. Love that. Critical thinking.
And then, wait, don't talk about that. And then
Alright, how do you look, you guys?
You might have to redo it.
Okay. Alright, we're back. We are back. Okay, so here's the test. Pop quiz. Y is a positive number. What number should we make y? 100. 100.
Why?
So we did 10 before, guys, but remember what we were looking for is, in that particular problem, we were looking for the area, so we were ultimately going to multiply by 10 to get an area of 100. Here, we want to start with 100. Whenever you can start with 100, that's the bet. So if we start with 100, it's equivalent to increasing y by 40%. So whenever you're dealing with percentages, guys, make sure that you are, and you guys, I'm sure you got this, but I want to make sure that we're calculating at each step. You can't just increase by 40 and decrease by 50 and expect that you just went down by 10, right? Rookie mistake. So if we went up by 40%, what's 40% of 100? 40, beautiful. So then we went up by that, so now we were at 140. And then we decreased that result by 50%, which means we were at what? 70, good. So we were at 100, we went down to 70, which means what happened? We lost 30, we decreased by 30. And again, because we started with 100, there's no further calculation needed. The difference itself is the percent change. If we were starting with a different number, then we would have to calculate it, okay? And while we're at it, just write down the formula, just to have it in case you didn't know it. Whenever you want a percent increase or decrease or change, it's going to be the change over the original times 100. And the change is just the difference. So we went from 100 to 70, so the change here would be 30 over the original of 100 times 100, which is why those two cancel out. That's why we always want to start with 100 whenever possible. It makes calculations easy. No calculator needed. Any questions on that? Awesome. Oh, speed bumps. Okay, let's go with, who has not read for me, would like to? And whoever it is, can you raise your hand and then pronounce your name, because I probably just haven't called you because your name's probably more complicated than I wanted to attempt early on. Who wants to read? Who hasn't read? You don't have to read, just raise your hand, tell me if you haven't read yet. Okay. What's your name? Oh, yours was the one I was going to tackle next. Okay, so this is one of the problems that can trip up a lot of students and be awful and terrible all at the same time. So here's what we're going to do. We've got variables in the answer choice. So what have we learned so far that means? We're going to make up numbers, exactly. Now, again, it's all about making up numbers and making your numbers work for you rather than just random numbers, because you can make up random numbers and you can go through the calculation. That helps, but we can make this easier. So what's a good number that we can make 10? Yeah, no, that's good. Or make x 10, right? So 10 or 20 or something, because then what does that do for us, guys? It means that now our speedboat is traveling at what rate? 1 mile. That's okay. He's slow. It's not very fast, but no one says he has to be fast to be right, okay? And he's every y seconds. So here's part 2 of the quiz. What are we gonna make our y? 60 seconds. Brilliant. That's exactly what we're talking about. Because now we've taken care of our conversion. Because actually now we can say that the speedboat travels at a rate of 1 mile every 1 minute. So then how many miles will the speedboat travel in? What do you want to make Z? 2. I love it. You guys are on the same page. So how many miles will he travel in 2 minutes? 2 miles. That's it. Right? So by making obviously our x something divisible by 10 makes your life really easy. And then whenever, and this happens a lot, guys, you're going to have a lot of these problems where you're trying to convert your, where you're dealing with minutes and you're also dealing with seconds, and then you have to deal with that conversion. It's not a hard conversion necessarily, but it's one more area that you have to worry in, one more place where you could potentially mess up. So if you just turn y into, or anything dealing with seconds, into a multiple of 60, and then just forget seconds really ever happened, write it down somewhere, and then deal in terms of minutes. So now we just need to plug in our answer choices to see which one is going to give us 2. And I know little birdie told me the answer is E, so let's work it out. So we have 6 times x, which we made 10, times z, which we made 2, over our y, which we made 60. And bam, 2. Any questions? Make up numbers, make it work for you. Is that stunned silence? You guys are wowed by my math skills? That's what I kind of sensed, so. All right. I'm going the wrong direction here. I don't know what's happening.
Give it a
I
second.
think I just need to be patient. I don't think I'm patient enough for this thing.
Zoom out. What happened?
I don't know. It got all blurry. I don't know what's happening in my life right now. I don't know what it is. I broke it again, guys. It made it blurry. I know I made it blurry. I don't know. Oh, I think I hit too many buttons again. Alright guys. Okay, who's going to read number 13 for me?
Small learning curve.
Next to you is
It's cool. It's like first time.
Nargis. You read it for me.
Which of the following relations best describes the information in the graph?
Okay, so this one is sort of just randomly placed because there's not really a lot of strategy to it necessarily. But there kind of is if you want. So guys, the important thing to learn about this is I'm going to teach you what you need to know about the transformation. But remember that equations that relate to graphs have an x and a y for a reason. So whenever you have a graph on your test, you can always pick numbers. Literally, it's kind of manual, but you could literally pick these numbers, whatever they are, that you actually have direct coordinates for, and plug it into each of the answer choices to figure out which one works. But here, this is simple enough. So, what does it mean? How do we indicate that the graph is unhappy? It's rounded. You get it?
That was good.
Why is he unhappy? Because he's negative. And And if I were negative, I'd be unhappy, but I'm a positive person. Okay. The other piece of it, so we know it has to be something with a negative, so that means that we are down 2. And then we know that it is, so we know that because it is over this direction, oh, except not that direction. I don't know, I'm gonna practice, guys, I'm gonna practice.
Hit the box on top
What?
right.
No,
PC, top right.
Square is a line.
This little box. There you
Oh,
go.
thank you. You just always have to sit right there so you can help me out with these things. Okay, so guys, which is it, A or E?
It's on the wrong side.
It's E, guys. Whenever you're moving the graph left or right, guys, focus, almost done. Whenever you're moving the graph left or right, what's the left and right axis? That's the X. X is on the inside. So if you don't know that, write it down. X is on the inside of the parentheses. Y is on the outside, and it's always opposite. So we went what would be, it looks like it should be like going positive on the x-axis, but because X is opposite, it's a -2, and it's got the negative, so that's what we're looking for. Any questions on that? We have a lot of graphs and stuff that we're going to go over, guys, so depending, we're going to find out as we go where you're stronger and weaker. And then the good news, guys, I'm about to tell you good news. The good news is that the way that this curriculum is going to be designed and the way that it works for these classes is it's going to evolve with you. So it's another reason why I want you guys to ask as many questions as possible, or give me feedback, let me know, say, you know, oh yeah, I already knew that, or this is helping, or I need more of that, or I have no idea, or that's helpful. What that's going to do, that's going to allow me when I come in again on Wednesday, when I come back on the following Monday, I'm going to make sure that I'm constantly pulling problems that I know that you guys are either not yet exposed to or having a difficult time with. So if you are completely quiet, it makes it a little trickier for me, because then I'm just going to kind of pull out of a hat, and that's always have the best results. So 14, who wants to read it for me? Who hasn't read yet? Go for it. What's your name?
Cassie.
Cassie. Oh, it's an easy one. I don't know, I missed that.
If g of x equals squared plus x minus 20, and a is x squared equals the graph of y equals g of x plus the y-axis value of
Okay, so here's another good news, guys. I never want you to memorize anything that you don't absolutely have to memorize, right? So whenever it asks for something like this, like where's it across the y-axis, if I have a graph and I cross the y-axis, let's just say there. What is that point? It's, what is it? Like 0, 3-ish. And if I cross it somewhere else, like this, it's like 0, -2. But what do I see that keeps happening? What will always keep happening? What's the pattern that starts forming? X is 0, that's the pattern. So if you memorize that your y, when something crosses the y-axis, the x is 0, and the x-axis, the y is 0, that's fantastic. I don't think I have enough room to keep all that kind of information just constantly going in my head. So what I do is, and what I want you guys to start doing, is we're going to start developing ways of figuring some of this stuff out quickly, problem solving, finding patterns, and that's how you're going to be able to make sure all of it's in there. If it's already in there, locked and loaded, fantastic. So what that means is, if we know that the x is 0, and we need to know, what do we do? Well, remember the thing I said where there's an x and y and it matters? So our x is 0, right? So we just say, okay, well, if I plug in my x is 0, then we have 0 squared plus 0 minus 20. What do we get? Minus 20, that's it.
Wait, I already see that. Yeah.
Any questions on that? Is this helping? Are you having fun? Anything? Feedback?
Feedback.
All right, radicals. Okay, who wants to read this for me? Go with Jessica.
By the door.
All right, that's concise enough. I'll take it. Okay, equation that they're asking us to solve. So, guys, this is this is fairly easy. Remember, when you're just multiplying, 3 radical 3 literally just means 3 times the square root of 3. So they slap them next to each other, but it's no different than any other multiplication problem. So really, on the top here, we're just multiplying 4 things across. You can go ahead and cancel out your 3's ahead of time if you want, whatever, it doesn't matter. So we end up with 12 radical 9, and what's the square root of 9? 3. So we have 12 times 3, which is 36 on top. On the bottom we have 3 radical 2. Now, obviously that's not there. So remember, rationalizing, they're a big fan of that. I don't know why, it's just a big pain in the butt. So we multiply by rad 2 over rad 2, because rad 2 over rad 2 is what? It's just 1, right? So you can do that, you're just multiplying by 1. So then on the bottom here we have rad 2 times rad 2, which is 2 times 3, which is 6. 2 times 3 is 6, right? We're all on the same page? Good. And then it crosses out here, so we've got 6, and we've still got that little radical 2 on top. So we have 6 rad 2. Any questions on that? We're going to do a lot more, so don't worry about all the rules for radicals. But this is another one that is just kind of sort of seemingly random in there. So I wanted to get that done. 16, who wants to read 16 for me? Yeah. You looked, right? So you win.
F of x equals x squared minus x plus 4, at which points does the graph of y equals f of x cross the x-axis?
Okay. So this is kind of similar to what we did before, right? What do we say? That if it crosses the y-axis, then the x is 0, and the x-axis, the y is 0, right? So what are we making 0 here? Y. Good. So we're just solving. We're just saying y is 0 equals x squared minus x plus 4. Everyone with me? Everyone remember your factoring skills? FOIL/factoring? Yeah. Again, these are the points when you want to tell me, like, you don't have to say it right now, but if something like this comes up, like, being serious, guys, if we go through, because I know that what happens, and I was explaining to the students before, is as you go through the higher and higher math levels, that's fantastic because you're getting really good at hard math, but what can happen is your lower level math skills, the stuff you learned in 8th grade, 7th grade, 9th grade, can kind of fade away a little bit, because if you don't do it every day, you're not going to remember it. And I definitely don't ever factor in real life, so only on these math things. So if you forget, it's okay. I'm not saying you guys did, but if anything like that comes up where you say, hey, Sarah, I need a refresher on this, I just don't remember it, no judge, just let me know so we can go over it. So right here we have x, we know they're the same, we know that they're 2, 2, so then what do we know? It crosses the x-axis at oh, yeah, you're right. Oh, quadratic. You guys remember the quadratic? And they also gave you a nice little graph, which helps, huh? What's a quadratic, guys? Talk to me? Yeah.
Plus or minus the square root of b squared minus 4ac over 2a.
Yeah. Guys, you will need that for this test, so if you don't remember the quadratic, write it down. Guys, raise your hand if you need the quadratic, so I give it to you so you can put it down on your paper. Okay. It is x equals minus b plus or minus the square root of the quantity b squared minus 4ac all divided by 2a. Also never used in real life. Okay, we go through this, guys. What do we get? Imaginary numbers, right? So what does that tell us? It does not cross the x-axis. And we also know this, guys, because where is our y-intercept? Plus 4, right? So, yeah, it's positive, it's at 4, so it's not going to go to x. Not unhappy. Not negative. Good. 17, which of the following equations best describes the curve above? Okay. So, in the interest of time, guys, I'm going to start going through these, and then if you have any questions, we're going to walk around and answer. So for 17, guys, you should get C. 18, C. And then we have 19 and 20 I'm actually going to go over because I want to, those are strategy based. Alright. 19. Actually 19, I want everyone to take a minute. I want you to work out what's the strategy for 19. And what's your strategy for 20? Make up numbers, both of them, guys. First one, we have a fraction. We don't know how many people are actually there. And the second one, we only know how the candy relates to the other candies. Remember, when things are just related, we make up numbers. When we're dealing with fractions, no certain values, we make up numbers. So take the next 5 minutes, and we're, no, 2 minutes, 3 minutes. Make up numbers, and we're going to go over it.
Happened in the two back sessions, it's in our garage.
Is that the right hand? That's where they keep the laptops.
Yeah.
I don't know if you need
Yeah,
it tilted.
but I have one in the house that's. Huh?
And I'm eager to so like when you go through like a long process like that, you come out being the expert on it. So it's cheap. I want to understand like better what we're going.
How are we looking, guys? You guys should be number making up next.
I gotta stop it, bro.
Yeah.
It's gotta be the setting, right? I'll work that at home.